Clovis tools sweep across North America by the thousands, yet not a single human bone until a construction crew in Montana unearths an ochre-stained infant among 125 ancient artifacts. For decades, his silent presence posed the ultimate question: who were the first Americans, really? Now, ancient DNA finally delivers an answer that overturns a century of debate and links this child to millions alive today. How did one tiny burial rewrite our understanding of an entire continent? Fluted spear points, chipped with remarkable skill, turn up by the thousands across the continent. From the Atlantic coast to the Pacific, more than 10,000 of these distinctive Clovis points have been catalogued, their sharp grooves designed to pierce the thick hides of mammoth and mastodon. Archaeologists find them scattered in ancient riverbeds, prairies, and caves, evidence of expert hunters who flourished at the twilight of the Ice Age. Alongside these weapons, stone scrapers, blades, and bone tools reveal a culture deeply attuned to the demands of survival in a vanished world. Yet, for all the artifacts left behind, the people themselves remain invisible. No campfire burials, no skeletons beside the tools, just a continent-wide trail of stone with no human story to anchor it. This mismatch between the abundance of tools and the absence of bodies leaves a gaping hole in the archaeological record. Who wielded these points? Where did they come from, and where did they go? The search for any human bone connected to this toolscape becomes not just a scientific puzzle, but the key to understanding the very first Americans. In 1968, a gravel pit operation on the Anzick family ranch in Wilsall, Montana, uncovered something no one expected. Workers found the scattered bones of a young child, mixed with a cache of ancient stone and bone tools. The remains, later named Anzick I, belonged to an infant no older than 18 months, whose life ended more than 12,600 years ago. The bones were stained with ochre, a rusty red mineral carefully dusted over the body, a gesture that speaks to ritual and remembrance. Archaeologists counted nearly 125 artifacts around the burial, including fluted spear points, antler rods, and scrapers, all crafted with the same skill found at Clovis sites across the continent. This was not a haphazard deposit. The tools lay clustered beneath a rocky overhang, suggesting deliberate placement and a sense of ceremony. No other Clovis burial has ever been found in the Americas, making Anzick I both a rare individual and a vital link to a vanished world. While the discovery was accidental, the significance was unmistakable. For the first time, the story of the Clovis people could be told not just through their tools, but through the fragile bones of one of their own. The remains were carefully transported to Texas A&M University, where they waited in storage, holding secrets that would one day reshape our understanding of the first Americans. Inside the lab, the promise of ancient DNA comes with daunting challenges. The bones of Anzick I had weathered over 12,000 Montana winters, enduring cycles of freezing and thawing that shredded genetic material into fragments barely a few dozen molecules long. Less than 2% of the DNA extracted from the remains belonged to the child himself. The rest, a tangle of microbial invaders and environmental contaminants. Every step demanded extreme caution. Researchers wore full protective gear, sterilized workspaces with ultraviolet light, and filtered samples in isolated clean rooms to keep modern human DNA from slipping in. The team ran duplicate extractions at separate facilities, cross-checking results between Texas A&M University and the Max Planck Institute in Germany. To verify authenticity, they searched for a molecular fingerprint of age called cytosine deamination. It is a chemical scar left as cytosine bases decayed and transformed into thymine over millennia. This pattern, concentrated at the ends of DNA fragments, confirmed the sequences were truly ancient and not the product of modern contamination. Rigorous computational analysis filtered out any stray modern DNA, and mitochondrial and nuclear checks found contamination levels below 1%. The resulting genome, though pieced together from countless tiny shards, stood up to the strictest standards of ancient DNA research. Only after clearing these hurdles could scientists trust that the genetic code of Anzick I would reveal the real story of the Clovis people. Bringing the Anzick I genome to light required a rare blend of expertise and personal connection. At the center stood Sarah Anzick, a molecular biologist whose childhood memories included the day her family's Montana ranch became an archaeological landmark. Decades after that discovery, Sarah joined forces with researchers from Texas A&M University, Montana State University, and the University of Copenhagen. Their collaboration drew on the strengths of each institution: Texas A&M University's long stewardship of the remains, Montana State's local perspective, and the University of Copenhagen's cutting-edge genetic analysis. The team included Eske Willerslev, a pioneer in ancient DNA, and Michael Waters, a leading American archaeologist. Sarah Anzik's role bridged worlds. She was both a scientist at the bench and the living link to the land where the child had been found. Her determination helped guide the project through years of technical and ethical challenges. The group achieved an average genome coverage of 14.4 times, a level of detail rarely reached in ancient DNA studies at the time. Their findings were published in a landmark 2014 paper in Nature, setting a new standard for collaboration and transparency in ancient genomics. The effort was not just about sequencing DNA, but about honoring the past and connecting it to the present through rigorous, respectful science. The publication became a touchstone for researchers worldwide, marking the moment when the story of the Clovis people could finally be told in their own genetic language. Genetic analysis of Anzik I's remains delivered a decisive answer. His DNA revealed a close connection to a 24,000-year-old child from Malta, Siberia, an ancient population rooted deep in Asia, not Europe. The Y chromosome placed him in haplogroup QL54, a founding lineage for Native American men that branched from Asian ancestors nearly 17,000 years ago. His mitochondrial DNA belonged to D4H3A, a rare maternal line still found among indigenous groups along the Pacific coast. No trace of European ancestry appeared in the genome. The long-standing Solitrian hypothesis, which imagined Ice Age Europeans crossing the Atlantic, collapsed under the weight of this evidence. The Clovis story, at last, had a genetic beginning. Genetic comparisons placed Anzik I at the root of a vast, living family tree. Outgroup F3 statistics showed his genome shares more ancestry with 52 Native American populations than with any other people on Earth. In practical terms, about 80% of indigenous peoples in Central and South America carry a stronger genetic link to this ancient child than to anyone else. Even today, communities like the Caritiana of Brazil and Maya descended groups echo his DNA in their bloodlines. In the north, roughly 1/5 of Native Americans, such as the Cree and Ojibwa, trace their roots to a related but slightly older branch, revealing a deeper tapestry of migrations and kinship. The story is not just about distant ancestors, but about living descendants connected by an unbroken genetic thread. In 2014, the Anzik child was returned to the Montana earth, not far from the rocky overhang where his grave was first disturbed. Representatives from multiple tribes gathered for a ceremony that blended prayer, song, and offerings of sweet grass, honoring the child as an ancestor and restoring his place in the land. This act of reburial did more than close a chapter in scientific discovery. It recognized the deep stewardship indigenous communities hold over their history. Archaeological evidence now places humans in the Americas long before Clovis, with Monteverde in Chile dating to about 14,500 years ago, and ancient footprints at White Sands, New Mexico, stretching back as far as 23,000 years. The story of the continent's first peoples reaches far beyond a single burial, woven through millennia of presence and care. Today, the genetic legacy of Anzik I lives on in millions of Native Americans. As technology uncovers new layers of our shared past, every ancient genome reshapes how we define ancestry and belonging. The search for identity isn't finished, it's just begun. What does ancestry mean to you?